Okay. First thing is lens. Okay. So here the total story of lens I will discuss today, and what are the applications, what type of problems are coming in previous years. We should discuss that one also. See here, first of all, if you consider a lens, to construct a lens, you will take one center here. Okay, you will take one center here and draw the arc. You will take from center here and draw one more arc. Okay, so drawing the arcs. After that, what will you do? You will draw one straight line. This is called as O, which is called as optic center. That is called as optic center, center of the lens. So here you can draw one line also, optic center. See here, if a parallel beam of light ray falls, okay, so here any parallel beam of light ray falls on the lens, parallel beam of light ray falls on the lens, there is one point where all the lines will meet. This is called as focal principle of focus F1. All the parallel beam of light ray which are flowing from this side will meet somewhere here, and all the parallel beam of light ray coming from the other side will meet somewhere here. Okay, this is called as principle of focus F2. Always take from left side first, from right side next. As you take parallel beam of light ray from left here first, all will converge, means meet at one certain point. That is called as principle of focus. Now, to draw an arc, I told you that you have to take one center. You have to take one center and draw the arc. You have to take one center and draw the arc like this. Okay. Then what is this? First, this side will come from left. If you consider from left, as you write from left to right, here also diagram you have to consider from left to right only. As you come from left, to which curvature come first? This curvature will come first. So we write C1 here, and next that curvature will come. We write C2 here. Then once you write this one, here from optic center to this, it is called as focal length F2. From optic center to the other side, okay, this is called as focal length F1. From optic center to the center of curvature, it is called as radius of curvature R1. From this center of curvature to the optic center, this is called as radius of curvature R2. Understood? So this is going to be the total construction of a lens. So this is called as principal axis, which is always passing through the center of the lens. Now, from this lens, we have created one formula. The derivation of formula is not necessary for us. It is learned already in your second year. Derivation is not necessary. But the most important formula where we are going to do the problems is called as lens maker's formula. Okay? So LMF is called as lens maker's formula. What is this formula telling here? Let us see and try to solve the problems based on this. So lens maker's formula says that 1 by f is equal to mu minus 1 by r1 minus 1 by r2. This is called as lens maker's formula. As I said in the construction, if you take from the left side, first curvature is this one, whose radius of curvature is r1, which is on the other side actually, but to understand I will write left side only. This is the next curvature which is taken as r. Understand? So this is r1 now, and this is called as double convex lens. Why it is called as double convex lens? Okay. So this is the first radius of curvature. It's called as a double convex lens. Double means what? This side also convex surface. And when it is called as equiconvex lens, when we call as equiconvex lens, when both the radius of curvatures are going to be same. But you should remember one thing here. What is that? See, this is the curvature which is this side, whose center is right side. So which is called as plus r. Next, this is the curvature whose center is left side. So we take always r2 as minus r. Because this is an optic center which is considered as origin. Which is always considered as origin. Whatever comes left side of an origin is taken as negative. So this curvature center is left side, so minus r. And this curvature center is right side, so taken as plus r. So we use this formula here and find out what is the focal length of the lens here. Let us see. Okay, so 1 by f is equal to mu minus 1 by r1 is taken as positive, minus r2 is taken as minus r. So 1 by minus r becomes plus here. Okay, so what do you get from this? You will understand that 1 by f is equal to mu minus 1. So 1 by r plus 1 by r is taken as 2 by r. So this is called as focal length of a convex length which is taken as r by 2 into mu minus 1. This is the formula for focal length of a equiconvex lens. Both the curvatures are same. Radius of curvature is also same. This is called as equiconvex lens. And this is the formula for focal length. Then what is the formula for power? See, you know power is nothing but reciprocal of focal length. Power of a lens is called as reciprocal of the focal length. So P can be taken as 2 into mu minus 1 divided by r. That's called as, okay? Is it okay? So P is equal to 2 into mu minus 1 by r is said to be the power of a lens. This is called as equiconvex lens. Now let me discuss about what is the meaning of equiconcave lens. So equiconcave lens means this is a concave lens. Don't write, I will send everything. Because if you start writing what is happening, you know, your concentration won't be on the board, okay? Writing in the focus, okay? So this is a concave lens. And whose radius of curvature is R1, radius of curvature is R2. When radius of curvatures are different, we call it as double concave lens. Double. This side also concave surface, that side also concave surface. Maybe radius is same, may not be radius is same. But equi lens, if it is called as equi lens, if you call, then we say R1 is taken as minus R because this is the first curvature coming whose center is left side, which is taken as minus R. Next, if you take this curvature whose center is right side, so we call it as plus R. Is it understood what I am saying? Now, what is the lens maker's formula explained here? 1 by f is equal to mu minus 1 by R1 minus 1 by R2. Okay. So, what do you understand from this? See, this curvature is coming first whose center is left side, and I told you this is an optic center which is taken as an origin here. Okay. So, this is R1 whose center is right side, so that's taken as plus R. So, by using this lens maker's formula, 1 by f is equal to mu minus 1 by R1 is taken as minus R plus 1 by R2. Sorry, this is minus. So, minus 1 by R2 is taken as R. So, therefore, 1 by f is equal to mu minus 1 minus 2 by R. Therefore, focal length is taken as minus R by 2 into mu minus 1 is the focal length of a concave lens, which is called as equiconcave lens. This is the formula here. Always for a concave lens, focal length is always taken as negative. Even power is also negative. Power is taken as reciprocal of focal length, which is minus 2 into mu minus 1 by r is going to be the power of the lens. Understand? So how to find out the focal length by using this formula? Here, it is always understood that refractive index of a lens, refractive index of a glass is taken as 3 by 2. Is taken as 3 by 2. Is it understood what I am saying? Is taken as 3 by 2. Therefore, focal length is equal to r by 2 into 3 by 2 minus 1. What is that you are going to get now? If you take this one. So you get f is equal to r. 3 by 2 minus 1 is 1 by 2. So 2 into 1 by 2 getting cancelled. So always focal length is equal to radius of curvature if the lens is made up of glass, whose refractive index is always constant. And that's going to be 3 by 2 or 1.5. So now, similarly, if you see the focal length of a concave lens, it is considered, and that too, the concave lens made up of a glass, always glass is 3 by 2, it's going to be 1.5. It's not going to change. Is it understood what I am saying now? Okay. So therefore, f is equal to minus r by 2 into 3 by 2 minus 1. So which is nothing but f is equal to minus r by 3 by 2 minus 1 is nothing but how much? It is going to be, so 2 gets cancelled. The focal length of a concave lens is taken as minus r. Understood what I am saying now? This is called as equiconcave lens. Now let us discuss about plano-convex lens. Okay, so this is going to be the plano-convex lens. See, first plane surface will come, next the concave surface will come. So plano-convex lens. Vex means this side is. Okay, for a plane surface, where is the center? Somewhere at infinity. Plane surface center is somewhere at infinity. So I will take this R1 as infinity, and I will take this R2. This is the curvature whose center is left side. So therefore it is taken as minus R. It is taken as minus R here. So we use the same lens maker's formula. 1 by f is equal to mu minus 1 by R1 is 1 by infinity. Minus of minus 1 by R2 is nothing but 1 by R minus, so it's taken as plus here. Understood? So let's make this formula is 1 mu minus 1 by r1 minus 1 by r2. This is the formula which is not going to change here. It's a general formula. Sign conventions we have to take according to the curvature. So this is the curvature which is left side, so taken as minus r. Okay. So therefore 1 by f is equal to mu minus 1 by r. Therefore f is equal to r by mu minus 1. Is it okay? And the power of the lens is nothing but reciprocal of focal length, which is nothing but mu minus 1 into r. I think you understood now? Yes? Plano convex lens. See, double convex lens is the formula. What is the formula for double convex lens? If I compare these two, how you will get? See, f is equal to r by 2 into mu minus 1 is going to be the double convex lens. See here. If you observe, what are we going to see now? See here, this is a plano convex lens. Focal length is half. When convex surfaces are 2, focal length becomes half. Why? What is the reason? I'll tell you. What is the reason? I'll tell you. See here, if you take the equiconvex lens here, and this is the principal axis. If you take a plano convex lens, and this is the principal axis, I'll see that whenever a parallel beam of light ray falls, it is going to converge at one place, which is called as principal of focus F1. Now, if it is only one surface is plane, one surface is curved, what happens? A parallel beam of light ray, when it touches a curved surface, it will converge at certain different places. See, this curvature and this curvature is same, let us imagine. Then what happens? The focal point will be at this place. Okay, so here the radius of curvature is this much. Sorry, focal length is this side radius of curvature r, and this also r. This is minus r, that is here this is minus r. So see the focal length here. See, focal length in this case is f. Here focal length is going to become, previously if it is f1, f2 will become 2 times of the focal length here. When double curvatures are there, so double curvatures, more bending of light takes place. It converges, it focuses very close to the optic center. When only one curved surface is there, one plane surface is there, parallel beam of light ray falls, it bends a little bit lesser. Rendu curvature inkoti vachindanago. That is the logic behind this plano convex lens. So I told you what is the focal point of the plano convex lens is f is equal to r by mu minus 1. Now let us go for plano concave lens. So this is a plane surface and this is going to be the concave surface. So here, if this is the concave surface, see, R1 equal to infinity, surface infinity, and R2 is going to be plus R. dV curvature. This is the curvature whose center is right side, so that's taken as plus R. Hope you understand what I'm saying now. Then after that, if I apply the lens maker's formula, mu minus 1, so mu minus 1 by R1 minus 1 by R2. Okay, so 1 by F is equal to mu minus 1. 1 by R1 is 1 by infinity. Minus of minus 1 by R2 is minus R. Okay. So what are you going to understand from this? Sorry, plus R. So this is plus R. So 1 by F is equal to mu minus 1, 0. And this is minus will be there. So what is getting now? Minus 1 by R you are getting. So therefore focal length is nothing but minus R by mu minus 1. Is it understood now? Okay. So this is a plano, first plane surface will come, so this will be plano and this is called as concave. Cave ante guham, it's a low vex. Understood? So this is a plano convex, plano concave, whose focal length is this one. So previously, if you take a equi lens, we got focal length as minus r by 2 into mu minus 1. And if you substitute the value of refractive index, I got minus r by 2 into 3 by 2 minus 1. As 3 by 2 minus 1 is 1 by 2 gets cancelled. You are getting focal length as minus r, just now explained. But what is the focal length in the plano convex lens if you substitute this formula? F is equal to minus r by 3 by 2 minus 1, which is nothing but 1 by 2. So this is nothing but minus 2r. Okay. So ikkada single curvature, ikkada double curvatures are there. So what is going to happen now? Why it is so? Why here principle of focal length is becoming? Why here focal length is becoming half? When you cut in the middle, ide cut focal length double it. What is the reason behind that? I will tell you the reason also. So now I have taken a equiconcave lens. I have taken a equiconcave lens, a parallel beam of light ray, a parallel beam of light ray, when it falls on the equiconcave lens, it gets diverged like this. Okay, and this is going to be the principal axis. And where they are going to focus, they are going to fall here. They are going to fall here. They are going to meet here. Okay, so this is called as focal point, principle of focus. And that is for what? Equiconcave lens. Now I will take a plano concave lens. I will take a plano concave lens. So if I consider a plane and this is a concave surface, see, ఒకసారి diverge అవుతుంది, ఇంకొకసారి diverge అవుతుంది. So from here it diverges like this, again it diverges like this. It meets here. So if you take a single plano concave lens, what is going to happen now? It falls and diverges only single time like this. Only single time. Okay? If it was diverging double time, it will, okay, it will meet very closer. But as there is only single surface, they will meet a little bit distance more. So you have to remember one thing, that what is that? If you take a lens, okay, if you cut the lens in the middle and take only one part, previously focal length is f, now focal length will become 2f. Focal length gets doubled. Now you have taken an equiconcave lens whose focal length is f. If I cut exactly in the middle and place somewhere like this, then what happens to the focal length? If it is minus f here, it is going to be minus 2f for plano concave lens. Understood what I am saying? Now the next thing is here. Previous year there was one question which was asked like this. I have taken one plano lens is connected to one plano concave lens. One plano convex, one plano concave. Both are combined together, placed. Then what happens to the net focal length? If the focal length of the convex lens is f1, this is f2. Here, curvature is same for both, no? Is this the curvature is same for both or not? That means for f1 is also f, f2 is also f. But if it is a concave, it is minus. If it is a convex, it is going to be plus. Focal length is going to be plus. So how do you write the combined focal length for these two? Combined focal length for these two, if the refractive index of the first one is mu1 and the second one is mu2. The simple thing you do is the resultant focal length, the net focal length is going to be 1 by f1 plus 1 by f. Just like resistances we write 1 by r net is going to be 1 by r1 plus 1 by r2. In the case of parallel connection resistance we write like this or not? For resultant focal length also same concept you have to apply. 1 by f net is equal to 1 by f1 plus 1 by f2. So 1 by f1 plus 1 by f2. So how do you write the net focal length? How do you find out the net focal length? What is the method to find out the net focal length? 1 by f net is equal to, see this is a type of lens, plano concave lens, for which focal length f is nothing but r by mu minus 1, which is minus. Understand? And for this concave lens, f2 if you consider, which is r by mu minus 1, if you take this as first one, you take mu1, this is second one, you take mu2. Later, reverse వచ్చిందనుకో, first mu anything you can do. Okay, first plano convex, then plano concave. Just change the values. This f2, this will become f1. Okay, now you have to write what is f1 here. Just see what is f1 here. Downwards is r. This is going to be mu2 minus 1. Okay, going to be mu2 minus 1. And what is this? First one is f1. F1 means mu1 minus 1 by r, and it's going to be minus. It's going to be minus. Okay, plus mu2 minus 1 for the plano concave lens by r. So what is the net focal length? 1 by f net is equal to r is going to be the common denominator for both. So minus mu1, minus of minus plus 1. So minus of mu2 minus mu1. So what is going to get cancelled here? Just see, 1 gets cancelled. So 1 by f net is equal to, in the numerator, mu2 minus mu1 by r. So what is the formula for net focal length for this type of? So r by mu2 minus mu1 is going to be the net focal length. Understood? Now, what is the next formula which we are going to discuss here? See, sometimes he is asking one concave lens, another concave lens, both are made up of glass 3 by 2. Okay, And what's going to happen? In the middle one, if you place the liquid here, here, what is the refractive index of a liquid? We don't know anything. Refractive index of a liquid is something else. Mu L will be something else. Okay. Then what do you have to do here? See, two convex lenses, and in between the gap we are pouring the liquid whose refractive index we don't know. We have to find out that one. Then what will you do? 1 by F net is going to be 1 by F1 plus 1 by F2 plus 1 by F3, just like parallel resistances. Okay, first you will take the first one, you will take the second one, you will take the third one. Okay, so the first one you will write here that the focal length of the first one is F1, is a equiconvex lens. Equiconvex lens means R by 2 mu minus 1. Okay, and F3 also same, because both are same lenses having same refractive indexes. Both are same values. So apply the same formula for both. F3 equal to F1 equal to R by 2 into 3 by 2 minus 1. So F3 equal to F1, which is equal to R by, okay. So how much will get? Just 1. Because 3 by 2 minus 1 is 1 by 2 and these two gets cancelled. So finally you're getting how much? R, the same one. The middle one is the different one. We don't know what is the refractive index. So middle one, if you take 3 is equal to, it is, see, when you place the liquid inside, it is behaving like a concave lens. Equiconcave lens. Then what is the formula here you are going to write? Mu of a liquid minus 1 by 1 by R1 minus 1 by R2. By using this formula, finally you get F3 is equal to R. Equiconcave lens means R1 equal to R2 equal to R, same. Okay, but the thing is minus you will get 2 into mu of a liquid minus 1. Already I have derived this formula for equiconcave lens. If he gives you what is the liquid here, if the liquid is given as 4 by 3, just like water. If it is given as water, what will you do? 4 by 3, right, and find out what is the focal length. And if he asks you to find out the right focal length, you just write now 4 by 3. If you substitute, what will you get? This is going to be minus R by 2 into 4 by 3 minus 1. Find 1 by F. Find, you got F1 as F2 as R. And this one also will get some value. Take all the values, substitute here, find your net focal length. Is it easy or not? So, two convex lenses, equiconvex lenses, in between liquid is placed. There is one more model here, always repeated. What is that? See, two plano-convex lenses are there. Okay, and in between them, liquid is placed. So, two plano-convex lenses, in middle, equiconcave lens is there. No need to get worried. Once you know the basics, what is that? Nothing is difficult for you now. This is take first one, this is take second one, this is the third one. See, focal length of the first one and second one is going to be same. Third one is a liquid. First, second, you write it as R by just mu minus 1, not 2 mu minus 1, because 2 mu minus 1 is for equiconvex lens. This is a plano-convex lens. We write just R by mu minus 1, where this R is taken as this one. This is 3 by 2 minus 1, which is 1 by 2, which is taken as 2R. So therefore, F1 equal to F2 is equal to 2R. If he gives you radius of curvature as some 10 centimeters, you will get that focal length as 20. Understand? In the previous case also, if he gives the radius of curvature as 10, okay, then the focal length F1 will be equal to F2 is equal to 10 only. We get 10 centimeters is the focal length. Here also you write minus 10 divided by 2 into 4 by 3 minus 1 is nothing but 1 by 3. So therefore 30 by 2, which is nothing but minus 15 you get. Okay, so simple it is, but most of the students will leave this type of problems. They will never attempt the problem also. They feel it's very difficult. So how simple it is? See, focal length is how much here? This is minus 15 now. Just apply this formula 1 by F net. F1, F2 are both same here. So 1 by 10, middle one F3, both are same. Middle one is 1 by minus 1 by 15. Middle one is a concave, minus plus 1 by 10. Understood what I am saying? Get the final answer. Get the net focal length by using this formula. Hope you are understanding what I am saying now. So if this is the case now, what will you get now? Focal length, the radius of curvature is given as 20 means focal length will become how much? Double kada? 20. See, radius of curvature is given as 10, then focal length will become double here. For which it is double? For this focal length F1 is double 20. For this also it is going to be 20 centimeters. Middle one, refractive index of a liquid, generally we take it as water. And water is not going to change, it is always 4 by 3 only. Water, the refractive index never changes, it's going to be 4 by 3 always. Okay, so what are we going to do for that? 1 by f, see, this is a equiconvex or equiconcave formula, middle one. Okay, this is 1, 2, middle one is 3, let us imagine. So F3 is going to be R by minus R by 2 mu minus 1, equiconcave. Plano concave with a 2. That's it. That's a small difference. What is the toughness here? Just tell me now. So radius of curvature we have taken as 10 here. So 2 into how much? 4 by 3. Liquid, no? 4 by 3 minus 1, which is minus 10. It's going to be 4 minus 3, that is 1 by 3. So 2 into how much? 1 by 3, which is F3 is going to be how much? Minus 30 by 2, minus 15. If this is not going to change in the previous case also, minus 15 only, because here also equilibrium will not change. Next time, will you do the same process? Never do. You understood. Okay? You understood very clearly that glass means focal length equal to radius of curvature. Glass. Water means focal length equal to minus 15. Equiconcave lens under minus 15. What I am saying. So simple it is. And the formula is not going to change here. The same formula will apply. Okay? So here also one plano convex, one equiconcave, and again one more plano convex. So the same formula 1 by f net is equal to 1 by f1, middle one is 1 by f2 plus 1 by f3. Write always positive signs only. But while solving, what will you do? 1 by f net is equal to 1 by f1. What is f1 and f2? This is going to be how much? 20 or 20. So 1 by 20 and middle one is 2. Second one which is minus 1 by 15 plus 1 by 20. Because it is a plano convex, so 1 by 20. Hope you are understanding what I am saying now. So simple it is. Now you can solve any problem. Okay, most of the problems are given in the previous year questions are based on these lenses. Okay, so hope you are understanding what I am saying now. Is it clear? Now just see here. One more concept which is very important. I have taken the lens and this lens is kept in air. Lens is in air now. When the lens is in air, what happens now? See, you know 1 by f is equal to refractive index minus 1 by r1 minus 1 by r2. This is a equiconcave lens whose refractive index is refractive index and area. Now, I will place this same lens, okay, this same lens inside the water. I will place the same lens inside the water. This is the water, let us imagine. So, here water is present inside the, surrounding the lens if water is present, then what will you write the formula here? See, the formula will become, see, this is focal length in air because lens is kept in air. This is focal length in water, surrounding is water is refractive index of water with respect to air is going to be 4 by 3. Refractive index of glass with respect to air is taken as 3 by 2. Then what will you write the formula here? Now, it is refractive index of glass with respect to water minus 1. Which is 1 by r1 minus 1 by r2. Try to understand what I am saying now. This is a small difference. If you keep the lens inside the water, it is refractive index of glass with respect to water. Now, what is glass with respect to air? If it is glass with respect to air, we write it as 3 by 2. If it is glass with respect to water, means refractive index of glass by refractive index of water. Glass with respect to air, water with respect to air. Understood? Because I told you already, refractive index of 2 with respect to 1 is nothing but refractive index of 2 by refractive index of 1 with respect to air. I told already while explaining the refractive index. The same thing I will apply now. So refractive index of glass with respect to air is 3 by 2. Water with respect to air is 4 by 3. So 3 3s are 9, 4 2s are 8 by 9 by 8. Refractive index of glass with respect to water is 9 by 8. And this is directly in air, so 3 by 2. Is it understood what I am saying now? So simple it is. How much simple it is? Just see. Now I want, okay, the question is asked in previous year like this. What happens to focal length if lens is kept in liquid? The same lens when you keep in liquid, what happens to the focal length? See, it is given that focal length in air is 4 centimeters. Focal length in air is given. This is already given. And he is asking us to find out what is the focal length in water. W, focal length in water, focal length in air. So divide says the first water will there. 9 by 8 minus 1. It's going to be 9 by 8 minus 1. So what are we going to get now? This is 1 by 2 and this is 1 by 8, which is nothing but 8 by 2, which is nothing but 4. So what do you understand? What is the general formula? What is the shortcut I have derived now? A wonderful shortcut you got now. What is that? See, focal length in water is 4 times of focal length in air. This already tells you you derive Jesus now. Next time when you get this type of problem, you never solve this one. You never do again. Just use the simple shortcut. Focal length in air is for 10 centimeters means focal length in water how much? Just multiply with 4. So, okay. So focal length in water is 4 times of focal length in air, which is 10 here. So your answer is 40 centimeters. That's it. Understood? So this is the total story of lenses. Now one more thing is cutting of a lens. If you take a lens like this and cut along the line which is passing through the optic center like this. So if you cut, what will you get? You will get this one different and this one separate. If the focal length of this is f, what is the focal length of these two? 2f and 2f. Understood what I am saying? Now I'll take one lens like this and cut like this. Now I am cutting like this. Now I was cutting in this way. I am cutting like this. So upper part is like this and the lower part is like this. If this is having focal length f, this is having focal length same f, and this is also f. It's not going to change because thickness is same. Focal length is not going to change. If you cut in the middle, focal length becomes double on both the sides. Understood what I am saying now? Okay. Next, if I take a convex lens and I silver this side, I will apply the silver coating on one side of the lens. Then what happens to the light ray will enter from this side, from air, enter into the glass lens one time, again reflect back because it is silver, no? Reflect back. So again it passes through the lens second time and again comes out. So as you have silvered the lens, the light ray has passed through the lens 2 times. As it has passed through the lens 2 times, what is going to happen? What is going to happen here? This is equal to one convex lens plus one curved mirror plus one more convex lens. This silvered lens is equal to 3 different objects. Because first time it is passing through the convex lens, so one convex lens. Again it is touching the curved surface which is acting like a concave mirror. So this is the second one. Second time also it is passing through the lens. It is also going to the convex lens. So as 2 times it is passing through convex lens, it is equal to 2 lenses and one curved mirror. So what is going to happen now? What is going to happen now? What is the focal length of the first one, which is nothing but r by 2 mu minus 1. And what is the focal length of the curved mirror? It is just half of radius of curvature. So focal length of a curved mirror is half of radius of curvature. Next focal third one is again r by 2 mu minus 1. Okay. So now, how do you find out the net focal length in this case? It is nothing but 1 f net is nothing but 1 by f1 plus 1 by f2 plus 1 by f3 here also. So 1 by f net is nothing but f1. We write it as denominator r. 2 into mu minus 1 plus 1 by f2 is nothing but r by 2 plus again r is in the denominator. 2 into 2 mu minus 1. Hope you understand now? Yes. So this is the formula we have to apply here. Then what is the final result you are getting? So 1 by f net is equal to 2 mu minus 2 plus 2 mu minus 2 and LCM is going to be the same here. Okay. So minus 2 plus 2 gets cancelled. Finally 1 by f net is equal to how much you'll get? 2 mu is going to be 4 mu minus 2 by r. So therefore f net is going to be r by 4 mu minus 2. Therefore f net is equal to r by 2 if you common out, it is 2 mu minus 1. Understood? This is going to be the formula for silvered equiconvex lens. Understood? Clear? Next, for example, one plano convex lens is taken. Okay? One plano convex lens is taken here. And what is going to happen now? And this side, it is going to be silvered. Convex surface is silvered here. What's going to happen now? If convex surface is silvered, what is going to happen now? The light ray will enter and pass through the lens for first time, reflect with the concave mirror and pass through the lens second time and comes out. So this is equal to one plano convex lens plus one curved mirror, concave mirror plus one more plano convex lens. Understood what I am saying? One more plano convex lens. Here, what is the focal length of this? First one, which is r by mu minus 1, already I told you, and this is f2 which is said to be curved mirror, concave mirror which is taken as r by 2, and this is again f3, which is nothing but r by mu minus 1, is it? So what is the net focal length of a plano-convex lens whose convex surface is painted? What is going to happen now? 1 by f net is equal to 1 by f1 plus 1 by f2 plus 1 by f3. 1 by f net is equal to 1 by f1 means how much? R mu minus 1 plus r by 2 plus third one r mu minus 1. So simplify all these. So if you simplify all these, f net is equal to r is going to be the LCM common, mu minus 1 plus 2 plus mu minus 1. Okay, minus 1 is how much? Minus 2. Minus 1 is minus 2. Plus 2 minus 2 gets cancelled. So here, what is the final one? F net is equal to 2 mu by r. So focal length net is going to be r by 2 mu. For what type of lens? Plano-convex lens whose curved convex surface is painted. The second case is here. I have taken one plano-convex lens now in this case, and you observe that here plane surface is silvered with silvering is done on the plane surface. Now in this case, light ray will enter to the convex surface. It strikes the plane mirror and reflects back and comes out. So light ray is entering to the convex surface lens 2 times while going, touching the mirror, reflecting and coming out. So this is going to be similar to one plano-convex lens plus one plane mirror now, not a curved mirror, just remember. And this is one more plano-convex lens because second time also it is passing through that only, is it? So what are the focal lengths in this case? The first focal length is r by mu minus 1. The second one is infinity. Plane lens, focal length is going to be infinity. Then what happens to the third one? f3 is going to be the same one, mu minus 1. Is it understood what I am saying now? The same thing will apply. 1 by f net is equal to 1 by f1 plus 1 by f2 plus 1 by f3. So 1 by f net is equal to, this is r by mu minus 1 plus 1 by infinity is going to be 0. So again you get mu minus 1 by r like this, is it? So what is going to be the net focal length in this case? Okay, so 1 by f net is equal to r. This part is removed. So mu plus mu is going to be 2 mu minus 2. So therefore f net is equal to r by 2 into mu minus 1. Okay, so what do you observe from this? You will observe one wonderful thing here. That means this is behaving like a equiconvex lens. This is behaving like a equiconvex lens whose formula is going to be same. Why it is behaving like a equiconvex lens? Because this is a plano-convex lens whose plane surface is painted. Painted అంటే ఏమి? దీని ఫేస్ దాని లోపలనే కనిపిస్తుంది. ఎట్లా కనిపిస్తుంది? ఇది మిర్రర్ కాబట్టి కనిపిస్తుంది. అవునా కదా? So plano-convex lens, plane surface is painted with silver is just like equiconvex lens. Formulas are going to be same. Okay. So next, sometimes he is giving previous year questions if you observe. See like this. See here. This is one surface. This is one more surface. This is another type of surface. Okay. This is the same surface, and this is the other surface like this. So ఎన్ని రకాల సర్ఫేస్ ఉన్నాయి ఇక్కడ చూసుకో. How many types of surfaces are there? This is having refractive index mu1. Okay, these two are same, having refractive indexes mu2. Middle one is different. Okay, and these two are same. Okay, so these two are same. 3 different materials are used. What are used? 3 different materials are used to construct the lens. Then if a parallel beam of light ray falls on that, how many images you are going to see? Any sort of focus. How many times? How many places it focuses? See how many number of refractive indices are there. That many images you will get. This type of question is there in the previous years. So how many types of materials are used inside? That many types of image. That many images are formed. That type of question is there. So simple as it. Understood what I am saying now? So this is a story of a lens. I will give some gap. After if I get some time, I will take half an hour or 45 minutes. I will explain simple, compound and telescope. These things. Thank you. Clear?